In this lesson, we're going to examine families of functions, that is, quadratics that share some characteristics, and also possibly things that tell them apart. Kind of like your parents and you share some characteristics, but you also have some differences. Okay, so if we look at this first example up here at the top, we notice that we have y equals 2x squared, 2x squared plus 4, and 2x squared minus 7. Well, some things are true about all three of those. The fact that they all have the number 2 in front of the squared term, the same a value, means they all have the exact same size. They all have the same direction. The fact that they are in vertex form and they have an each value of 0 also tells us that they all have the same axis of symmetry. Now the other number tells us something different. They all have different y-intercepts. They have different vertices. Okay, so they have some characteristics that are the same, but also some that are different. We're going to look at trying to build equations today, which means we have to be able to solve for A. We also have to be able to work through the three different types of forms, because depending on the information we're given, maybe they give us the zeros, but we're asked for the vertex. Maybe they're giving us the vertex, we ask us for standard form. So we have to be able to work through the three different forms. So just reminders, factored form, we know that one. So I'm given a bracket x minus s and x minus t. To be able to go down to standard form, we FOIL. Get rid of our brackets, we'll get ax squared plus bx plus c. To get from standard form to vertex form, we can use our axis of symmetry. That is negative b over 2a, and you can plug it back into your equation to get your vertex. The one nice thing is, in all three of these forms, the letter a stays the same. So once you know your a, you don't have to solve for it anymore. If we're given the vertex form, we can get back to standard form by FOILing, and we can get back to factored form by factoring. Okay, so there's our three different types of forms. Let's try a couple. It's all about interpreting the information you're given. So a quadratic relation has zeros of -4 and 6. That's important. That tells me I can work with factored form. I've got zeros. It passes through a point. That's important because that's an x and a y. And we want to determine the equation in factored, standard, and vertex form. So all three forms. I know I can start in factored form, however, because of the zeros idea. So a bracket x minus s, x minus t. When we put our zeros in, we have to change our signs. So we get +4 now and -6. Make sure you have the letter a there because we need to solve for that. We don't know our direction of opening yet, nor do we know our size factor. To solve for a, we can use a given point. So y is 42 and x is 3. And we're going to do some bedmath to solve. So in the brackets, we got 7 and -3. We'll multiply these three things together, and we'll get -21a is 42. And if we solve that, a is -2. So in factored form, I now know -2 bracket x plus 4, x minus 6. That's factored form. First one. I want to go to standard form. Standard form means I have to FOIL. And I never want to get rid of brackets, I FOIL. On the brackets, we'll get x squared minus 6x plus 4x minus 24. We can collect, I'm leaving that 2 alone until the end. And then I distribute the -2 into everything, and I'll get this expression. There's my standard form. The third one, vertex form, I need to find the vertex. I have a choice here. Either way, I need the axis of symmetry. So I'll show you both just so we have them. My axis of symmetry, I can take my zeros, which I was given in the question, -4, +6, and average those, which gives us 2 over 2, which is 1. Or I can use standard form, the one right here, and use my -b over 2 a's, which also gives us 1. Either way, though, x is 1. I need to figure out the y part. How do I get the y? I use one of my equations. Again, I have two choices, standard form or factored form. I'm going to use standard just because I can see it on my board right now. replacing the x with 1, because I know that's what x is. I'll plug that all in, and we'll get, what do we get there? 48 plus 4, 52, minus 2 is 50. So why was that important? Well, my vertex is 1 and 50. So for vertex form, y equals a. Remember, we already solved for a. It's right there. Negative 2 bracket x minus h. The h is your part of your vertex squared plus k. And here's vertex form. Okay, so our three forms: some algebra skills, some rearranging skills. Let's try the next one. The diagram below shows part of the graph of this quadratic. The line x equals 2 is the axis of symmetry. Okay. M and n are points on the curve as shown. Find the value of a. Well, we're not given a, right? We have to find that out. How can I do that not knowing the zeros or the vertex or even any points on the graph? All I know is the axis of symmetry. But that's a really powerful thing, because we know the axis of symmetry can be found by using this little formula, negative b over 2a. I know what the axis of symmetry is, 2. I know what my b value is, because in the equation I can see a, b, and c, right? So b is 4. So negative b is negative 4 over 2 times a. If I have one variable, I can solve for it. In this case, I can solve for it by cross-multiplying. So 2 times 2a is 4a, so 4a is negative 4, a is negative 1. And now I have myself an equation. Okay, for part B, I want to find the coordinates of m and n. M is kind of nice, because m is a y-intercept. The thing we know about y-intercepts is x is always 0. So if I were to put 0 into my equation for the x's, I'll be left with just the negative 3, which hopefully remember is also called our y-intercept. So 0 and negative 3. If I want to find n, n is my vertex. Now the nice thing is I already know what x is. X is 2. All I need is the y. How can I get the y? Well, I have my equation, right? ax squared, except for we said a was negative 1, plus bx plus c. Here's my equation. N is 2. And if I put that in for my x's, I'll get negative 1 times 2 squared, 4 times 2 minus 3. And that will give us 8, 5, 3, 2, and 3. But the key there is recognizing what information I'm given in slightly different ways. Right? We're given the axis of symmetry. I can use negative b over 2a. I was given a y-intercept by the picture, the fact that it's on the y-axis, which means x has to be 0. It's about interpreting information. Okay, we're going to try a tricky one now. This time, I know my quadratic has roots of 4 plus root 3 and 4 minus root 3. So I've been given information, but I've been given it in an exact form, radical form, if you will. We know roots are also called zeros, which means I can use factored form. I'm given a point. So I'm really given the same information that I was given in the first example, except instead of having nice zeros like negative 4 and 6, I've been given exact zeros that involve radicals. But we can approach this in exactly the same way. Factored form first, because I've given my zeros. When I put my zeros in, I have to change their signs. So 4 plus root 3 has to go in as a minus 4 and a minus root 3. Change both signs. The next one, 4 minus root 3, goes in as a minus 4, but a plus root 3. I'm going to change both signs. I know a point, so I can put negative 6 in for y and 2 in for x. Same thing for the next one, so 2 minus 4 plus root 3. Now we're trying to solve for a, right? So we're going to do the BEDMAS idea. We're going to get rid of these brackets. But before I do that, let's try and simplify these brackets a little bit. So if we collect our like terms, we end up with 2 terms inside each bracket. Which means when I multiply them together, because we need to multiply this all together, I'm going to have to do FOIL with the 2 brackets. So negative 2 times negative 2 is 4. Negative 2 times root 3 is negative 2 root 3. Negative times a negative makes a positive 2 root 3. And at the end, I end up with a minus root 9. Now the nice thing is, we're still solving here, when I collect my like terms in the middle, those two things cancel each other out. And root 9 is just number 3. So I end up with 1. Or in other words, A is negative 6. So all that work that we had to do came out to a nice whole number. And to be honest, they should always come out to a whole number. The roots should cancel each other out. So factored form, we got to go back to the top, and we got to fill in the A values, the only thing that's changing so far. So minus 4, minus root 3, and x minus 4 plus root 3. There's factored form. Fortunately, we were asked for standard form also. So we need to get rid of these brackets. We need to FOIL. So let's leave that negative 6 alone, and we'll use the idea of FOIL. That is, we'll multiply the x times each thing, then we'll multiply the 4 times each thing, and then we'll multiply the 3 times each thing. So we end up with 9 terms, and hopefully some of those will cancel each other out. I'll give you a hint, they will. So x times x squared, x times 4, x times root 3 is x root 3. Let's do the 4 next. Negative 4 times x, negative 4 times 4, negative 4 times root 3 is 4 root 3. You know, do the root 3 one at the end, so minus x root 3, and plus 4 root 3, and then negative root 9. Out of room there. Okay, we'll collect our like terms before we multiply that 6 in. And I can tell you right now, if you're doing the right track, the roots will cancel out. So this root and that root have opposite signs. The 4 and the 4 have opposite signs. So when I collect, I get negative 8x, and then I have the plus 16 and the minus root 9, which we know is just the number 3. So in other words, plus 13. And I can multiply that 6 in, so 6x squared, 48x, and 78. And there's standard form. Even though it started with roots, it should never end up with roots. They should cancel each other out. Okay, last one. No word problem for us. We got Angus. He's playing golf. He makes a perfect shot over a 10-meter tall tree, that's shown in the diagram below. The tree is 30 meters from the tee box, that's where he's standing. And the pin is 100 meters away. Determine the height of the ball when it's 15 meters from the hole. So, we've got to interpret this information. We know our tree is 10 meters high. That's 10. We know it's 30 meters from the tee box. We know the pin is 100 meters away. So from here all the way over here is 100 meters. And we want to figure out the height of the ball when it's 50 meters from the hole. So let's call 50 meters this way. And what's the height right there? How tall is that? Well, looking at the picture, obviously this is a quadratic, right? So if we think of this as a quadratic that goes up and then back down again, we can put a set of axes on it. My suggestion is let's put the axes right here, because then we have some points on our graph. This point would be 0, 0. The pin, the hole, is at 100 and 0. The tree, which is 30 meters from the tee and 10 meters tall, can become a point, 30 and 10. And then if I want to figure out the height of the ball, 15 meters from the hole, I know that the ball has gone 85 meters. It's 50 meters short, so it's gone 85. All I need to do is figure out how tall it is. So if I had an equation for height based on distance, I can figure that out. Let's make ourselves an equation then. What kind of information do we have? We've got zeros. That suggests to me I use factored form. So y equals a bracket x minus s x minus t. They don't have to use this form, but I don't really know any other information. I don't know the vertex. I don't know the height of the ball. The tree is not the vertex. It goes past the tree. You can see in the picture. So it kind of really suggests we should use this factored form. If I plug in my zeros, x minus 0. The other one's at 100, so x minus 100. I know a point for sure on this graph, because the tree is 30 and 10. So the height is 10, when the distance is 30. And it's one of our standard questions now. Not a word problem anymore, just a question. So bed mass. Multiply it all together. Okay, we're going to end up with a really messy number here. Negative 10 over 2100 is A. Now, you can leave it as a fraction if you want. Nothing wrong with that. I'm going to use a fraction. Or if you want to change it to a decimal, you can, but try and keep it the exact decimal, because that's modeling our height. It's an important number. So our equation, let's get rid of one of the zeros. Just cancel 10 with a 10. X minus 0 and x minus 100. I want to know the height of this thing when it's 85 meters from the hole, 15 meters before the pin. So my x value will be 85. Put that in the wrong spot there. X is 85. So 85 minus 0, 85 minus 100. A little bit of bed mass. So 85 times negative 15. 15. And if I plug that all together, multiply it all together, we should end up with 6.07 meters. Okay, there's a little application of how we can use quadratics and recognize information to make equations, to actually use the equation. Homework today, try these questions. A good example, especially try the one with the radical in it, because you need practice on that. That's a really good test kind of question. I would expect you should be able to do that for our test in the upcoming days.